Hello everybody and welcome to another episode of No Orientation Programming. I'm Joe and today we will hopefully open our SSH channel of the gaming server. Last time we have finished our SSH authenticating process, and that means we have received a user and a password. This password must be hashed, and it's hashed with a SHA-256 and is stored as a result of the SSH authentication process. In the gamer interacting process, we repel the SSH authentication process as soon as we have passed the result to the user authorizing process. This process is started immediately, I think. Yes. It is created, then the arguments are set, and then it started. Yes. User out done wait. Okay. We start another process as well, and that is the SSH filtering process. And this filtering process so let's see. We increase the verbosity a little bit, the verbosity of the log, and then we check what is happening. Let's see. Let's see which processor are running at the moment. We have a game interacting process with the name Joe. Connection is secure. It has started an SSH transferring process. The remote version is shifted. Okay. So we have connected with an OpenSSH client. That is true. We have started the game selecting process already. That's fine. And an SSH filtering process. And the game selecting process is started because the user authorization process is finished. This is because we need to implement this process first. At the moment, it's assigning the username and the authentication ring immediately and then returns positive. And that's the reason why we have a game selecting process already, but we don't see anything here because we have to implement the filtering process, the SSH filtering process. As we can see here, the SSH client requested requested access to the service SSH connection with the method password. The password hash has been calculated, and SSH filtering process has been started in gamer indexing. The SSH authentication process was repelled, and the user authorization has been started. Then because the authorization process is returning positive immediately, it should be shut down as well. This is seen here, yeah. Processing done, so they're shutting down, and then it should be repelled. It should be repelled. Yes, it should be repelled. Let's see. Yeah, here. 100. In gamer interacting. Repelling. SSH authentication, yes, that's when repelling user authorizing. Okay. The SSH transferring process shows us that there is some packet, that we have received some packet. And this is because the SSH filtering process is reading the data. And now we have to process the data and finally open the SSH channel. So I will decrease the verbosity now again, because we just want to see what's going on in the next abstraction level. Okay. So the SSH filtering process is the next thing. The authorizing will be done later. Today I want to see a frame. Okay. Game detecting. Fine. That we can keep this file open. So this is it. I want the SSH authenticating state machine. As a template, okay. SSH filtering start. Connection pointer not set, they're fine. Timeout receiving authentic. No, that's wrong. Okay. Let's see, we can enable this. Receiving. So now we have to open a certain RFC. Which one? Not this. I guess this one. No, it's the authentication protocol. That's the connection protocol. And we get a channel open, I guess. Let's see. Channel open has the value 90. Timeout receiving channel open request. Okay, receive data, message authenticating. Okay, fine. Not as a stage, but SSH field state. SSH field state string. We should be in the state temporary authenticating. Why not? So let's see. Now we should see this message 2 times. One time in SSH transferring and one time in SSH filtering. That's fine. We get the size of the packet. We get the number of padding bytes. We get the number 5A. 5, what does 5 mean? 5 means 5 times 16. That is 80 plus A, that is plus 10, is 90. So it's a channel open request. That's fine. As we see in the connection protocol specification, the client wants to open a session. A session is started by sending the following message, yeah. 1 byte, 1 string, and 4 uints. Okay, fine. So let's see. We receive a packet. We terminate the packet. We check the message authentication code. Then we set the header. Do we have a header? Then we check if this is a SSH message channel open. If not, did not receive a channel open request. We should see here that we are in the SSH field temp state. That's fine. Still, that's fine. So we saw the right message. That's cool. Now we need a string that is called name channel. And we execute the function after we have got the right packet. We prepare our buffer pointers and we fetch the name of the channel. Could not fetch channel name. Otherwise, yes. If the name of the channel is not equal to a session, did not receive a session channel request, but something else. Received session channel request. Okay. That's still perfectly fine. Okay, I think. Now, we want to add another fetch function, because we want to be able to fetch buffer fetch from pbuff, and I pointed to an U integer 32. Fetch. Oh, come on. That's fine, yes. And what do we want? If len buff left is smaller than size of uint I think this is fine. P number and number is this. Nope. P len data. P byte. Plus equal to size of let me check. Okay. Const uint 32. Swapping from network order to host order long. Okay, then we fetch the sizes you insert to size or just number. Received a channel session request, that's fine, and now we yes, that should be fine. We have fetched the channel name, that is a string. We have checked the string. Now we should point to the first unsigned integer, the sender channel. We could SSH filtering. Yes, why not? I don't care about the padding bytes at the moment. Channel num channel sender num channel remote and number channel local. Number channel bin size init packet size max. Okay, let's see. Could not fetch sender's channel number. Could not fetch sender's initial window size. Could not fetch sender's maximum packet size. Received authentication, access requested, yeah, fine. Opening channel. Oh my god. Channel init win size. Oh, no. Oh, cool. And max get size. Channel number. Invalid conversion from blah 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 to P data. Let's see. No matching function for call. Reference. Name channel. Should I use a reference? Yes, I should, because I'm not checking the pointer anyway. Okay. Byte. Yes, okay, fine. So I use a reference here, and we should not mix it, at least. I don't want to call this byte. I want to call it whatever result number. Okay, that's a bit strange now. So the byte, we have to change byte to result, and this as well. Okay. Now we have a number. Reference, and somewhere we use the fetch function for a byte. Fetch. Yes, here. So we have to remove this. Now let's see. Okay. Now we have. Let's see if this makes sense. Kind of. We have a channel number of 0. And we have an initial window size of this number. I guess this is 1 megabyte. And that is 1024 times 1024. And 16 kilobyte of max packet size, yes. So the window size, what is the window size? The SSH channel, the SSH channel has a flow control mechanism, and I think each side is telling the other side how much bytes it can receive at once. And then the communication must be stopped until the receiver has processed some bytes and has told the sender that more bytes can be sent. So, okay. So this packet is fine. So a client implementations should reject any session channel open requests to make it more difficult for a corrupt server to attack the client. Okay. Requesting a pseudo terminal. we have to reply to this packet. Yes, we don't have a channel specific request, but let's see. This is the window adjust. The window size specifies how many bytes the other party can send before it must wait for the window to be adjusted. Both parties use the following message to adjust the window. Each side has its own channel identifier. In this case, the sender has the channel number 0, and we reply with an okay, and we have to tell the sender our identification number for his or for its channel. Let's see. Okay, that's it. SSH, we have to send an SSH message channel open confirmation. We give the sender channel and the recipient channel, our channel number and the channel number of the sender. Our initial window size, the maximum packet size, and channel type specific data. Okay, so that is fine. And we confirm the channel. Channel open confirm. Like this. Well, let's make it a response. Confirm. Yes. Come on. So, oh, let's see what is this. Do we have mpcon? Yes, we have an mpcon. Okay, we make a message. How big is this message for? 8, 9. Yes, let's make a reserve. Oh, that's big. Why is this so big? A length, a byte, another byte. Password. Let's plop. Yes, okay, but this failure. Okay, if we send a failure, one 4 8 16. Okay, let's yes, okay. Okay, it's fine. Okay, len at byte, that's the header. We don't have an okay. We send a length. Nope. First we send an SSH message channel open. confirmation and a length. Yes, length. Okay, that's fine. The name is strange now, but okay, fine. Recipient channel. Oh, I think this is the sender's the remote channel number, I think. Win size init. Initial window size. Oh, let's see. I just want to receive that much bytes and okay. This is our local channel number and we increase the local channel number, and if I think this is okay, then we have an initial window size and we have a packet size max. And then I want to see what we have sent. Message data, message size. Oh, come on. How was this possible? Okay. Was not declared. Channel open confirm. Yes. No. What? Channel open confirm. Channel open confirm. Fine. Opening channel. We have sent a confirmation. Continuing to server selection. So what is happening now? Hello? Okay, let's see what is... Oh. Why? Okay, this was because of the telnet session before. Okay, let's see what happens if I make this. Yes, okay. Send packet type 98. Oh yes, okay, that's I understand what is happening. In the on the client side, we send a channel 0. What did we get? Authentication method password. Send packet type 50, the channel open request. We send a password packet, wait for reply. Receive packet type 52. Authenticated to localhost using password. Yes, fine. We create a new channel. Client session. The client sent a packet type 90. Entering the interactive session. Received packet type 91. Channel input open confirmation. Sending environment. Okay, now this thing is sending stuff. Okay. Send packet type 98. Ignored environment. Okay, let's see. What is this thing sending me? Are there any passwords stored in the environment? Hopefully not. Type blah 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 blah, home username blah blah blah, non-session user. Okay, that's fine. So we get a packet. The client tells us that it sent a packet 98. Open confirm. We see our sizes here. Let's try a different one. The win size init. The packet size max can be, let's say, bigger. Then we say, see, the window size is 32 and the maximum packet size is 64. It's fine. And what is a packet 98? Let's see. Filter, SSH filter. what should we get? What is this? What kind of packet is this? The 98 SSH message channel request. That's a message channel request. Okay, we have opened the channel, and in the channel we have a request. Okay. The channel is opened. We have confirmed the channel. Channel specific requests. Many channel type values have extensions that are specific to that particular channel type. An example is requesting a PTY for an interactive session. Okay, we are opening a session and we are opening a specific type of session. A PTY session, I guess. Interactive session. Interactive sessions. 6.1, and yes, I think it's opening a you know what, I want the local channel number to be something different at the beginning. 7 is a good number. And I think, yeah, I think we should get this string term environment variable value. Encoded terminal modes. Okay, I think we get this packet now. That means we have a state that is called SSH. Thanks for the follow. I hope the chat is. I don't know if the chat is working. I hope the chat is working. I reopened the chat. I don't know. Twitch had a. It does. Oh, thank you for testing. It's so bad. Sometimes the chat is not working, even for not everyone. Thanks for testing. And thanks for the follow. SSH filter request. So we want to distinguish, I guess, the channel request. I renamed this state because it's an channel open receive wait. So first we wait for the client to open the channel, and then we wait for the channel request. So, and that means we need a new state. That's fine. Okay, and then we just have to do some of the stuff again. That is, we at least check this stuff again. Received the data length. We check the message authentication. If the message authentication is fine, then we timeout receiving channel request. If then we should remove this. Did not receive a channel request. The first packet, we call the first packet channel open, and as in the RFC, we don't want the log to be confusing. So at this stage, we tell the user if we have received the timeout receiving the channel request. Okay, fine. As the message code, we need SSH message channel request, And let's see if we see. Now we should see this packet. Okay. Okay, that's fine. The client tells us it has sent the packet type 98. And what did we get? Oh yeah, fine, okay, nice. So we have confirmed the channel open. And now what kind of channel? It's a session channel. And what kind of session? It's requesting a specific session that is a PTY request. And that's this packet. Let's see if it wants a reply. Yes, it wants a reply. So we have to pass this packet. Then again we will show the passed data. We are in the filtering process and I want to deactivate this. We don't need this anymore. And now we are passing the stuff again. And then let's see what so yeah. The client requests a PTY channel, PTY session. And we have to make a reply. But first things first, oh, come on. Oh. Recipient channel. Let's see what's standing in the recipient channel. That is, that's 7. That's cool. That's 7. So we have to check everything we get from the client. Okay. Oh, okay, as before. We need now I copy this whole stuff. Did we receive a channel request? Fine. We set the buffer pointer and now we are okay. We are receiving the recipient channel, and that's we save this number at num. Could not fetch recipient channel, and then we check if num is not equal to our local channel number, did not receive oh, come on. The hell. Recipient channel number does not match is none. Okay, received channel request, and here we have to say received channel open. A channel open for session. Channel open for session. Channel open for type, whatever. Type session. Opening channel, fine. Receive channel request for our channel. Okay. Now. Does not match. Yes. Now we fetch a string. Could not fetch. The request name, I think. The could not fetch request name. Yes. Could not fetch channel name. Yes, perfect. Could not fetch channel name, and here we have could not fetch request name, and here we have to check if the string is not equal to a PTY request, then did not receive a PTY request, but something else. Yes, otherwise we have received PTY request. Okay. That's so bad. B. Let's see what this B for byte. Now we have to pass B. Could not fetch. Want reply. This is important later. Okay. The terminal environment variable. The type of terminal. Yeah. Encoded terminal modes. Oh, come on. Term type. Could not fetch terminal type. Should we? I think the terminal type is any type. We cannot check this type, I think. Oh, come on. Term width in characters. And the height in pix. Yes. And term mode. Nope. Yes. I have to rehydrate. Rehydrate. Okay, so terminal type. And now we check the terminal width. And I could not fetch term width in chars. And height in chars. Okay, fine. Pix. And now we have the final thing. Could not fetch terminal mode. PTY. Boah. So. Type. Width in chars. Height in chars. The type is S. Term type C.C string. Pixels. Chars. And the last. Oh yeah. So this should be it. Oh, broken pipe. Why? Recipient channel number does not match is 7. Ah. Mm. I have increased. Oh, I have increased the channel number. The current channel number. Next current. Don't know. And the next one is the current is the next one. And then the next one gets increased. And yes, seems to be fine. The next one is 7. Yes, I think this is fine. Oh, broken pipe. Could not fetch terminal mode. Terminal mode. Okay. We have one triple. What? Okay. Let's see. What did we pass? We have a number. Then a string, a number, the channel number 7, then a string happens to be 7 as well. 1, 2, 3, 4, 5, 6, 7. Yes, this is the length of the string. PTY request. This is the bool if it wants a reply. String received PTY request. This is the B. Want reply. Terminal type. B. This is the terminal type as string. String is E. E means 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Then we have the width and the height in characters, and then we have the width and the height. Oh, yes. I understand. long is this packet? Oh no, oh, come on. This packet is quite long, I think. Oh, how big is this packet? In hex 1-4C. Hey, 1-4C. That's quite big. I will change this. What? That's very big. Oh, come on. Ah, yes. The whole environment. And not the terminal modes. Oh, come on. Oh. Yes, never ever. Yes. And that's it. Mode. Terminal mode as string. The encoded terminal modes are described in section 8. Zero-dimension parameter must be ignored. The character row dimensions override the character row dimensions override the pixel dimensions when non-zero. Okay. So parsing was done, but we cannot just print the mode here because, and we can remove this. The mode, okay, we have stored the mode in a string, but we cannot draw it like that. Okay. Step by step. We are almost there. Okay, so, but as we can see, we have width of characters and height of characters. We do not have any pixels, and we got a lot of modes, whatever they mean. But now, what can we do? As we can see here, there is a channel-specific request. Many channel type values have extensions that are specific to that particular channel type. An example is requesting a PTY for an interactive session. These 4 fields are present in every request, I think. All channel specific requests use the following format: the channel request, the recipient channel, the request type in ASCII, if it wants a reply, and the type specific data. So everything below want reply, in this case the terminal stuff, is specific to the PTY request. And in any case we have yeah, here want reply. If want reply is false, no response will be sent to the request. Otherwise, the recipient responds with either SSH message channel success or failure, or request specific continuation messages. If the request is not recognized or is not supported for the channel, failure is returned. This message does not consume window space and can be sent even if no window space is available. The values of request type, because we have to check we have to check later if we get any data from the client. Then we have to check if we tell the client the change of the window size. If we receive data, if we receive data from the client, then we tell the client the change of window size, the bytes left the client can send us. If the client is faulty or bad in any way and it sends more data than we want to receive, then we have to check the remaining bytes we offered to the client, and if the client is sending more, then we have to cut the connection. And in this case, because of the that's interesting. The request. This message doesn't. Okay, the request, the channel request does not consume window space, and I guess the returns does not either. These messages do not consume window space and can be sent even if no window space is available. This message, this is referring to the channel request message. Okay. So neither the request, the channel request, or the success or failure responses are consuming window spaces. They are control packets. Further waiting for the response to the request. Okay, request type. Okay, we have to send this. Okay, fine. Channel open confirm, channel request success sent. Step by step. Okay. Yes, come on. And now I'm convinced. So this packet is so small, it just needs 1 byte, 4 bytes. So we reserve 8 bytes. No more. Come on. I forgot these two. Yeah, whatever. This would be an annoying bug. So we don't need to see this anymore, but we want to see this. Channel SSH message channel success. Yes, this is the length of the packet. This is the length of the padding bytes. This is the message code, and we have to add the remote channel number, and that's it. We send this to the client, and now I think we should be oh, nice. Request shall confirm. type send packet type 98. Channel input open confirmation. Yes, we have opened the channel and received packet type 99. Channel input status confirm. PTY allocation request accepted on channel 0. So, this is our success message. And now, after that, what is happening now? We have opened the session, we have opened the PTY stuff. Can I send something now? Hello? Request accepted on channel 0. Okay. A pseudo terminal can be allocated for the session by sending the following message. The encoded terminal modes are described in 0 dimensions, blah blah blah. Pixel refer window error. The dimensions are only informational. The dimension parameters, okay, I don't need them. The client should ignore these requests, okay. We don't have an X11 forwarding request. We don't have an environment variable passing. So let's see what is... do we receive something? Let's see. We don't have a timeout. Yes, I think this is fine. So let's see. Let's check if we get any data after we have confirmed the stuff. Yep. Yes, we are receiving something. After the modes, we send the success thing, and then it's sending other stuff. These are requests, I think. Yes, this is a request. 62 is a channel request, so we get multiple requests. What kind of requests? These are environment requests. Come on. So okay, we get environment requests. So at this time we are in a the file should be between 300 and 500 lines. The code should be not too duplicated, but let's see in which direction this is going. But we have a terminal, so it's in multiple stages. At first we get the session, then we have a terminal, then we get some environments, as we can see here, environment requests. I think I cannot... Oh, yes. Cool. cool. I think I have sent something already. 60. Let's press enter. Ah, okay, I don't know. Come on. Ah, this is because come on, this is so confusing. This is why we get everything twice. So we just get two more requests, and now I press D for double cool, and D should be ASCII 64, hopefully. Come on. ASCII table. And what's D? D is 64, and this is this 64. What do we get here? Ah, these are requests. This is an environment request, and this is a shell request. Ah, we could make an request passing function. Yes. Okay, one moment. So, channel request pass. I think this is fine. And because every request has the same structure at the beginning, and I want to reuse the stuff a little bit so the code gets smaller. These two can be checked without a parameter. Okay, let's see. I have a pass request channel and channel request pass. And this passing function should do some checks, the first checks, and give me what do I want. This should get a std string reference, type, and jar want reply. Yes, these two things, it's passing the first structure of the request. Reference as well. Oh, come on. So now the first stuff should be the same. Gbuff. I think we should fetch fetch. Yes. We should return something else. We should return a const sharp pointer because I want the p buffer to be initialized. That is, the p buffer should be this thing, and it should store the request type and the one replying the B, and if we do not have a p buffer, then could not parse at the channel request. Could not parse channel request. Yes, that's fine. But if we have a p buffer address, then we can continue fetching the stuff. So the packet is okay. The packet itself is okay. And we check if we have gotten a request. And we have to be careful because it can be different for PuTTY and other clients. We will check what is happening after that. Okay. But I think the PTY request should be the same. I don't know if the environment request is in the same order. That we have to check this. But okay, let's make this function first. Okay. If we have passed fetch recipient request, could not fetch name. Yes, that's it. Oh, we have to change this. Determinate type received. No. Oh, what? This. Yes. Hey, thanks for the follow. We have to put this code up to here. Yes. We pass the channel request and we get 3 things. The position in the buffer after the passing, so we can continue the passing. Then we get the name, the request, the name of the request, type of the request, and we get a bool if we have to send a reply. So I put this code here for a moment. And I have to do something else because we did not check the B here. If B, then we just have one B. Let's call this want reply. If the client wants a reply, then only in this case it gets a reply. Okay. Correct. Yes, that's fine. B. Want reply. Okay. So. This header is fetched, that's fine. Then we need the p buffer. Oh, come on. Oh. The p buffer variable is initialized at this point. Yes, we have a header. This function gets executed if we have received a packet and the message authentication code is fine. So the packet integrity and authentication is fine. And that means we have a fresh packet. A fresh packet that is okay. We set the header pointer to the buffer. We check if this is even a channel request. Did not receive a channel request, but now we have to make something else. We have to return null. Oh, come on. That's fine. And we have to do this for every bad case. Otherwise we return the p buffer. Null. Oh. Come on. So this is it. B. Number. We have the p buffer and we check some number. We set the header pointer, we check the message code. We increase. We set the passing pointer in the buffer after the SSH packet header. We pass a number. What kind of number? Could not fetch recipient channel. And we check if this number is our current channel number. Recipient channel number does not match is should be then the request name or type request type, it's called request type. Could not fetch request type. The type is stored in the type. And we have a want reply, and that's cool because we have reused some code. That's fine. If we have passed the channel request header, then we can check if this is a request we expect. Received PTY request, and then we can pass the additional stuff. We could make a function for this. Let's see. We have the modes. Yes. Now we try to compile this thing again and see what unused variable number. That's true. Expected Okay, fine. Let's see. So we get a PTY request, we send a confirmation. Success. Don't need this anymore. Okay, we get a PTY request, we get an environment request, and we get, so it's setting the language to the locale to English, US, and it's requesting a shell. These are two requests. The shell request does not have any shell request specific options, but the environment of course has more data to be sent. Okay. So, but although, and that's very strange, although we have not confirmed these two requests, I can press D, and this D, I'm so stupid. I looked for the ASCII sign, but I have the ASCII sign right here, so I can press an E, and we have an E. I can press G, and then we have a G, and if I press enter, then we have, that's a D, a hex D. Okay. I can press hello, and then we have hello. Okay, so it's working already somehow. And now let's see what putty is doing. CD downloads and then wine putty. So let's see. I load this thing. I say connect once, yes, and then I press bar. Now login as foo and bar. So let's see what this thing is doing. As you can see, this is the banner message. This is sent by the authentication process. You are entering TGS. Welcome, my friend. Okay. So, and what do we see here? Okay. We see that as expected. I thought this would be like that. Okay. We have received a session request and channel open. and channel open for a session. And then we have the client sent a PTY request. And that's the same for both clients, but as we can see, the PuTTY client is only sending a shell request, but not, we see the client here, that's a PuTTY client, and the other client is an OpenSSH client. And the OpenSSH client is sending a PTY request with a lot of modes that we don't process at the moment. The type is xterm 256 color. What type do we have here? Just xterm. Ah, okay, so that's a different type of here. That's a different type of PTY. Different type of terminal, okay. We could check the type, the type as well. We could say that the type has to start with xterm, for example, if we want to be more strict. The size here is 172.41, and the size here is 80 and 24. Okay, it's requesting a shell. What if we press hello here? Ha! That's interesting. Hello. Nothing is... Okay. Fine. This was very important to see what is happening, because only at this only now I can know the structure of the code that we need. So I would say we call this state shell request receive wait, and the environment is optional, and we have a function that we call env request pass. And we do not need this at the moment. So we have a state. A state that is called shell request receive wait. We go into this state we are expecting this thing, so I want to see this thing coming in 300 milliseconds. I want to pass the thing, and then I want shall receive wait if that's dangerous. That is very dangerous what I'm doing. I'm not resetting the timeout, so we have a diff here. Then we need to restart the timer. And we have to restart the timer here as well. Okay. So, timeout receiving. Channel request. Yes, that's fine. Connection lost. Received data. That's not important. String. If string is equal to shell, else if string is equal to environment, then else received unknown, received wrong channel request. Fine. And if the channel request is a shell request, then fine, go to the next state. I want to rephrase this thing. I want to say if this is that, then execute function. I don't need this to return. Yes. Okay, let's. Why not? Could not pass. Env request. Oh, oops. So if we passed the request header, and if the request was an environment request, then we passed the environment request specific path. If there was an error, go out. If there was no error, just break and stay in this. Yes. Stay in this state, and maybe we could reset the timer because we got the message. Nope. So, and this, if this is not a shell request, always check ifs in a negative way. If this is not a shell request, then return received wrong channel request, blah 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 blah. Otherwise, we say we have received a shell request. And we have received a shell request. And if it wants a reply, this is important. If we get an environment request, yes, we have to do this here because in every case, if we get any request that is valid, like the environment request, we have to check, consume the entire packet. And then if we have finished consuming the packet, only at this point we can send a success packet. And only if the sender wants a reply for this request. So if we don't get the shell request, then other than an environment request, so in this state, the shell request receive wait and environment request is valid for us. That's fine. And a shell request, but nothing else. If we don't get a shell request at this point, then we stop. But here we have to send a success as well. Okay. If the sender wants a reply. Okay. So now we go to the environment path thing. We copy the stuff from here. I don't think we need a header thing anymore. Yes. I think we need this. Yes. Yes. Okay, that's fine. P buffer. Okay. We get the first P buffer here, and then we have to insert the P buffer every time. Okay, so it's not on the stack here. It is on the stack, but as an argument. And we have to fetch different things now. That is channel specific requests. Now, requesting a terminal, we don't have a x11, that's fine. X channels, environment variable passing, that's it. Want reply variable name string. It's just one. So okay, fine. Then we have a string name and a value, and that's it. Name could not fetch variable name. These two are strings. So I have to just print them. Okay, let's see if this is working somehow. Okay. Haha, cool. Ah, that's cool. No, oh, that's not cool. Yes, this is cool. Ha. Now, again, we reactivate this. Warning. Success. I print every time we send a success. We got a PTY request and we have sent a success. We should even make it more drastic. Okay, so we have received a PTY request and we have sent a success because the client wants us to do so. Okay, now the next. This is the success packet. Then this is the fourth byte in the second row. No, it's not the fourth. It's after the name, so it's a variable. In this request, the want reply bool is here. The bool is 0 or 1. Every sender has to use 0 or 1, but every value other than 0 must be interpreted as true. So in this case, the 1 is here, so we have sent the success. In this case, the thing is telling us a request, hey, take this environment variable optional. Its name is language and the value is enus. Because here we have a 0. The bool is here, in fact. It's not the fourth, it's the second. After env is here, and then we have a 0, and because this want reply is 0, we do not send a success. And then we have received another request, a shell request, and for this shell request the client wants a reply again, and therefore we send a success. And this success is seen here. PTY allocation request accepted, and the shell request is accepted as well. For the open SSH type hello now, hello. And as you can see, for the SSH client, this did not make any difference that we didn't acknowledge the shell request. But now it's getting interesting because I want to see what putty does. cd downloads wine putty. Connect once, I connect as foo, and I connect bar, and then this thing, and that's fine. That's what we want. We want to process optional environment requests, but if we get the shell requests, then we get into the next step. And hopefully we should be in the temp thing now. That's here, yes. Yeah, we are connected with both clients now. We are connected with OpenSSH. The OpenSSH client sent an optional environment request, but PuTTY did not. And for both clients, we are at the state SSH filter temp. That's fine. Okay. And now the interesting thing is, can we send something to PuTTY? Oh yeah. Oh yeah, oh yeah. That's definitely. Fine. That's interesting. That's interesting. The PuTTY client seems to be more strict than the OpenSSH client. That's very interesting. Because I had some other issue where I was able to connect with the OpenSSH client, but not with the PuTTY client. And the reason was that PuTTY did not accept the signature of the host key exchange reply. And the signature contains two numbers, and these numbers are unsigned integers. They need to be unsigned integers, so the first bit, it's a multi-precision integer, it's a very long sequence of bytes, and in the first byte, the first bit must not be set. And I tried to add a 0 byte in front of these two numbers every time, and the RFC says explicitly that there must not be any senseless preceding 0 bytes. So in this situation, I was not RFC conform, and I tried to be not RFC conform, and I wanted to see if I can connect, if I can still connect. And it was the case for the OpenSSH client. The OpenSSH client complained if I don't add the 0 byte in case of the host key, because the hashing function then is different, but for the signature it didn't care. And PuTTY did cared about the preceding bytes. So I've changed this, and then I was RFC conform, and PuTTY was connecting as well. And now it's similar. We have a similar case. The OpenSSH client seems to be fine if I don't, even though it's requested by the OpenSSH client, it seems to not care about if it's getting a reply or not for the shell request. But putty does not send any bytes if it does not get a reply, a success reply. Yeah, cool. Cool. No, that's so. I must say we are very close. Oh, we are almost at the end of the streaming session today. The filtering thing. What should the filter do? The filter should so I think I can ignore this if 0. The language, I don't care about the language at the moment. But it seems to be not important. The terminal modes seems to be not that important at the moment. After we have received the shell request, the filter, the input filter, it's an input filtering module. At this point, the input filter is doing what it should. It gives me the keystrokes. So, yes, that means I need another last state that is SSH filtering. We don't wait for anything else, so we don't have any timeout here. Telnet. What is telnet filtering doing? If you have a telnet client, then we have a much more simple thing. It's initializing the telnet client and then filter main. Okay, I have called it main. That's fine. And I have a function that is called keyget. Oh, that's cool. That's fine. Oh, yeah. Okay. Then we are finished with this module almost. Main. SSH filter main. I copy this thing. Yep. Fine. And we stay in this state and we have a dinit here. It's strange that was a strange case. I think this was a bug. There was one case where I didn't have a cursor anymore. This is not allowed. Okay, whatever. Now I just have to implement the keyget function. For the SSH filtering, and then we are done. That's it. And request pass. Yep. So I think this is a little bit different. What is happening if I press Control and C? Or Control and D? 3 and 4. Ooh, hopefully this is some kind of 3 and 4. Huh? Control C and D. Yeah, that's fine. 3 and 4. That's fine. Key escape is key. I hope this is okay. Enter was the same. Backspace is hopefully one of these. And escape is 1B. 1B in the OpenSSH. Yeah, this seems to be quite 7F. It seems to be quite. Yeah, quite compatible. That's cool. So for Telnet, PuTTY, and OpenSSH, we have the same control sequences. That's very cool. I don't need this. That's fine. Yeah, whatever. Okay. So, I reuse the code from I have to check what kind of message this is in. So, filter temp. Yes. Yeah. And then I think, yeah, this will be the last stuff we are doing today. So we are not as far as I thought we would be, maybe, but we have done a lot of stuff today. So, LAN requested. LAN requested is this stuff. Buffer LAN is something. How is the telnet? Okay. Deinitialize. This has a deinitialize state. Okay, then we make the same for the SSH filtering. SSH filtering the init. And that's fine for me. So we have a dinit state, and this in this dinit state we return at least these two things. We set the connection pointer to be done, and we say we have returned positive. Yeah, a little bit cleaning up, or the file is between 300 and 500 lines. That's perfect. That's so cool. Okay. If number 3, if smaller or equal than 0, then return 0. Is this fine for us? If it's smaller than 0, then the connection has an error and the end is set already. Let's see if... This is important for us too. Process. We have to check this in the process function. If the connection is done, then we have to return. So this means we can do the same here. We don't need the connection lost stuff. I think this is fine. Received data. We don't need this. That's fine. We have to check if the message authentication is fine. If not, we have to return 0 and we have to end the process and set the state to deinitialize. Otherwise, we have to check. We now have to check what kind of packet did we get. That means we need this whole stuff. We are almost done. So what kind of packet is this anyway? So yes, header. We set the header because the packet is okay. The message authentication code is fine. The message code, what kind of message code did we get? This is the length of the packet. This is the number of padding bytes and the 5E. 5 means 80 in decimal. And E is 14, so it's 94. 94 is what? 94 is channel data. Okay, so if at this point we don't get the channel data, I don't know how the clients behave exactly. Did not receive a channel data package. Code is, I don't know if they if the clients are sending me something else. So I print a warning, did not receive a channel data packet code something, and we do not end the connection at this point. we just make a warning and we print the hex data, hex dump of buffer and buff len. Okay. So we if we get an unexpected packet, then we print the packet so we can inspect the packet. Now we have to consume the data, environment variable passing, starting a shell command. Let's see what's. Once the session has been set up, a program is started at the remote end. The program can be a shell, an application program, or a subsystem with a host independent name. Only one of these requests can succeed per channel. Okay. A shell. This message will request that the user's default shell, typically defined in etc password in Unix system, be started at the other end. Okay. Execute. This message will request that the server start the execution of the given command. The command string may contain a path. Normal precautions must be taken to prevent the execution of unauthorized commands. Subsystem, fine. This last form executes a predefined subsystem. It is expected that this will include a general file transfer mechanism and possibly other features. Let's see what this thing is doing if we give okay. As here we have if key is user disconnect, then we have do the same here. Okay. Oh, my brain is stuck. My brain is stuck. Oh, what the hell? One moment. SCP port 4001. I want to send the file TGS to cat at localhost cat home password dog client loop send disconnect broken pipe. What is did not receive a PTY request, but environment. So this is different. So it's possible that we get an environment request here. Let's try to make it compatible with the it's 11. The streaming session would be over by now, but I'm motivated. Okay, let's first try to finish the key function. Let's try to finish the key function first. Okay. So if we don't get a channel data packet, then let's see what this is. Otherwise, we got a channel data and we have to pass the stuff. But what is in a data packet? Session data transfer data. Oh, fuck. Oh, come on, no. Oh, no, no, oh, I don't. Because now the whole flow control stuff is waiting for us. Session data transfer. Data transfer for a session is done using SSH message channel data and message channel extended data packets and the window mechanism. The extended, so these window packets are possible as well. So we have to check if we get any window packet. So we will get a window packet, and if we get a window packet, then we just have to return 0. And we have to make this different. If key then we got a data packet, we extracted the key and we commit the key and break. If did not receive received unexpected packet, and we show the packet. And we have to implement to do implement flow control. A flow control. That is the window mechanism. Okay. Implement flow control window mechanism. Okay. So we have a different function that is checking this the stuff if we have received enough data, if we have to ignore additional data. And if we get any unexpected packet, then we have to show the thing, and the question is if we should end the connection at this point, return positive. Why not? Okay. Let's just read what is happening here, and then we will raid somebody. I should not forget the raid. Session data transfer. Data transfer for session is done using the has been defined for standard air data. Window dimension change message. When the window terminal size changes on the client side, it may send a message to the other side to inform it of the new dimensions. Local flow control. X on off. No, let's just finish the key get function. That's fine. Okay. If the code is unequal to channel data, then go out. Otherwise, check. So, and that means SSH message channel data. We have to data transfer. Yes, and that's it. Okay. We have to could not fetch recipient channel yet. That's it. That's cool. And we have to check if we get the data for the right channel. That's still fine. Could not fetch recipient channel, and then recipient channel number does not match. That's fine. And then we have a string data. So we have a number and a string. A number, pbuff, yes, and a string. Could not fetch channel data. It's fine. Okay. Proc warning log. I expect to get only one key of data. So if the size of the data string is bigger or equal than 2, then we have received some strange data we did not expect. We print the str data and the str the size. Fine. Otherwise, almost done for today. A long journey. Otherwise, the key is the str at. Oh, come on. Is the hex dump function fine for hex dump while len? While len? Okay. It's not doing anything if the length is 0. I think. Yes, okay, fine. That's okay. So I can make it a little bit different. If it's not equal to 1, then I have received a 0 string, and that's strange. Only if it's 1, then I can access one element, and that's fine. So, key received. And yes, oh, that's fine. If key is used to disconnect, then the init. So, and this is the last stuff we will do for today. Key was not declared. Yep. Okay, we have 500 lines. Oh my. Unfortunately, this file will be a little bit bigger than expected. Bigger than 500 lines because we still have to implement the flow control. Maybe we can make it a little smaller. 408. If bufflen, bufflen is a size t. Yeah, that's fine. Yep. If not packet okay, then go out. We have an error. If we haven't received anything, go out and it's fine. If we have a connection error itself, then it will shut down in the process function because the connection is checked. If we have received something and the packet is okay, this is kind of dangerous. I have to change this later, but this will be in the next session because we are not allowed to read data for other requests. We have to get in the data and then check. We need to write a dispatcher. We have to read the channel data and then check what kind of packet is this, and then we have to dispatch the packet to the according function, to the needed function. Okay, but whatever, for the beginning it's okay. If we did not get a channel data, then go out. If we could not fetch stuff, then error. If the recipient channel number does not match, go out, error. If we have received some data length warning and hex dump and 0, otherwise key received. If disconnect, then go out, 0. Okay, let's see, this is the last thing. Ooh. Oh. Received unexpected packet. Received shell request success. Yep. Okay. Ah. No. I have to change this a little bit. Yes. Ah, come on. Ah, come on. If not, come on. Come on. So, if not buffering pending, and this if mpcon read. If not bufferland, then pending, and if smaller than 0, then connection lost. Otherwise, chuck, and check if the package itself is okay. If we don't get a package, then go to pending. So this is better. This is what I mentioned. We have to check here. Receive something. If we don't receive anything, then go out. No function does anything. If we get a connection error, connection lost, buffer termination, message authentication check. And then if we have received something, then these functions have to check if they are responsible for this stuff. For example, the key get function checks. The key get function knows that there is a packet that is valid, and it sets the header pointer and checks the message code, and if the message code is not for the key get function, then it returns 0, and we don't go in here, and only then we otherwise, if this is the channel data, then we make the whole passing stuff. Success. I press D and that's it. Now this is interesting because games list. I'm curious what is happening if I press the right stuff. Let's press Control C. What is happening then? Oh yes. Oh. I pressed Control C in the wrong window. I should not press Control C here because this is the server. The server got shut down. But what is happening if? Yes. Oh yes. Come on. Nice. Closed by remote host. Request a shell request. Getting got server list. Received data. Key received. This is an connection shutdown key, and because of that received an unexpected packets. Nah. Damn it. Yes, it's working, kind of, but if m state is not equal to whatever, I just if this is equal to the init, then it's done, it's fine. Then we have to break. If yes, so this key get function can do two things. We get the key or the state is changed. But it's connected. Control C, and then we have received the data. We have received the key. Cancel, but this key is not given to the key pipe, so it's just changing the state to deinitialize, and because of that we have removed the gamer, and we should see this here. That's fine. We have no gamer connected. We connect with SSH. We have a secure connection with the OpenSSH client. And you can see lots of bytes have been sent just after connecting 2500 bytes. All the key exchange and encrypting stuff and message authentication. It's a long way. It's quite a long way. So we are in the filter main state, and if we press Ctrl C, then the gamer gets removed. The same should happen if I press Ctrl D. Yep. And if game selecting process is a game's list, what if I press escape now? Oh, yes, the state machine of the game selecting process is cool. When I press enter, the connection should be terminated. Yes, because we are doing this at the moment. I connect with Telnet. I press enter. I'm here. This is the games list. We are not sending frames at the moment. But when I press escape, this is the exit ACK state. It's waiting for the user to acknowledge the exit, and if I press enter, then the cursor should be restored. But that's another problem. That's something else. Escape, yeah, that's in a different, yes, okay, that's not a big deal. We have just reinsert stuff. Okay, but the cool thing is the SSH stuff is working already. Escape, enter. We are in the state games list. Press escape, and we are in the state exit acknowledge. Enter. We have escaped. Okay, cool. What? That's a big stuff. Okay. Now let's see if we can do the same with putty. Where is putty? Remote set on. Yeah. That's fine. Okay. Yep. Let's connect. Connect once. Foo bar. Okay. Okay. Games list, that's fine. What if we press enter? Escape. Oh, I was not in putty. I was in. If I press escape. Yes. Okay. Escape in putty means escape from the GUI. Whatever. What if I press Ctrl C? No, it was not in the focus. Whatever. Oh, come on. If I press escape. This is a strange bug. So I'm in the exit acknowledge thing, and then I press enter. Remote site. Yeah. Shut down. The server is still running. Okay, let's try again. Load, open, once, foo, bar, enter, escape, enter, down. escape, enter is down. And if I press Ctrl D, what happens then? Open once, foo bar, Ctrl D. Remote site, yes. Closed because I have pressed Ctrl D, that is 4. Okay, so the SSH filtering process is fine. Big stuff, big stuff. Okay, so I am finished for the day. We have done a lot of stuff. Oh, okay. Oh, I should. This is January. Implement SSH. Add SSH channel filtering. Oh no, implement we have added. Yes, that's cool. Let's compile, let's connect with Telnet. Settings, version history, implement SSH channel filtering, that's fine. Next time we will add the frame for the frame. So what is happening? A short roundup. What is happening now in this thing? The parent process SSH authorize, user authorize. When a user connects with SSH and it's authenticating, if the user is authenticating via password, then we send to the user an authentication response, a successful authentication response, because we tell the user, okay, at first you are authenticated. That does not mean that the user is authorized to enter the server. But if we tell the user that the authentication is okay, then we accept the identity of the user, and we send the user, we let the user establish a session channel and a terminal, a shell session. And with this established channel, we can show the information to the user. We can show the progress of the authorization process, because, and that's what is done here, we wait until the SSH authentication is done, and if it is done, we send, okay, we accept your identity, and then we start two processes, the SSH filtering, that is establishing the channel, and another process that is called user authorizing. This process is talking to an internal process that is checking if the user is known, if the account is activated, verified, whatever. And during this phase, during this process, we show to the at first unknown user the process, what is happening. We are connecting to some external server. We're trying to verify your identity, and if you're authorized, then you can go into the server. So the next thing is creating this frame and informing the user of the progress. But for now we are finished, and I'm very happy with the result. Okay, so it was a long session, but a cool session. So Twitch, who is online? Who is yeah Reinventor. Playing. Botzler is soldering, I think. Maybe he's coding. Playing. Symphony is playing. Okay, let's see. Sliders Rust. Rust. I hate Rust. Yeah. Okay, let's make a coding session. Okay, let's rate Reinventor of Wheel. Maybe I get I learned something rusty. So for everyone who is still watching, see you next time on Thursday. I'm very excited for the result, for the today's result. Hopefully we see us again, and please rate with me Reinventor of Wheel. Reinventor of Wheel. Oh, Wheel. Yes, fine. Bye.